really complex and based on various things that you would normally see in your normal bank. So it's not, write a check, you get charged for it. It's things like, well, we'll go into it a little bit later. So their requirements, the business had a fees system, which was an older mainframe system, which essentially were working in a batch mode and generating fee statements every 6 months. But the business really wanted to up-to-minute view of fees to project the revenues. We wanted the ability to forecast. We wanted to go to a shorter billing cycle for the customers. And some of the fees example that you can see here, really the high level of complexity that fees represented for U.S. Trust. An example is if my portfolio contains more than 20% of Red Hat stock and my expensive artwork goes up in value 10%, and I'm late on my $20 million mortgage payment, and Fed had lower interest rate, and it's after May 1st, then my fee is about 1% of my real estate portfolio, and make sure that you send the bill to my summer residence. So this is some of the complexity that went into calculating fees for this ultra-wealthy clients. And the way they traditionally have done it is they actually had feeds coming out of all of these multiple sources, essentially all of these systems that service clients. All of these were really either cuts, off-the-shelf products or homegrown. So things like portfolio management, trading, banking, mortgage systems, market data, and so forth. Essentially generated feeds, which allowed then the mainframe to kind of churn this into, the fees. So again, the existing implementation was a bunch of mainframe and COBOL programs, but again, was not good enough for business. Again, not getting the real-time visibility, and the company's financials actually were impacted as well. So again, what would be the solution to kind of get real-time visibility, real-time reporting and forecasting in place for fees? Well, first, an event-driven architecture platform had to be put in place. So event streams were derived from legacy and COTS applications and distributed platforms. So we started out with publishing just the raw events through creating technology event adapters for funky things like IBM IMS, which is a database, a hierarchical database that IBM still sells and contained a lot of their data. MS SQL Server, some of the products ran on that. There were batch file feeds, CRM. So the first thing that we needed to do is we needed to have real-time events generated from these systems in some kind of a canonical event format. So getting these fine-grained events, when the customer's information changes, when a trade has been done, when a portfolio change has been done, all of these things had to come as an event stream, real-time, in order to be able to analyze it. And the second step was actually establishing a CEP platform architecture, which is actually going to intelligently analyze that event stream that's coming from different places and be able to aggregate into a coherent fees structure. So some of the components of CEP platform architecture were JBoss-MQ message bus, which contained topics that were segregated by business event type, basically by what each one of these systems produced. JBoss Cache with property change listeners as part of the JBoss rules. JBoss rules itself. CEP domain specific language, CEP DSL. This is, and if you take a look at the CEP product domain or CEP space, it's very difficult to express CEP language in a standard rules definition file or standard SQL. So there is a hybrid that's called CQL right now that's being worked. There are some standards that are in the works right now. But again, complex event processing requires its own specific language. So that's something that JBoss Rules platform allowed us to do out of the box to create this domain-specific language. JGroups was used for cache replications, and then we'll get into how JBoss Rules, how JBoss Groups and JBoss Cache work together to create the inverted database concept. And everything ran on top of a JBoss application cluster. So here's a picture of actually how this thing worked together. So essentially, as we see, all of these legacy systems were producing the events that were consumed on the JBoss-MQ message bus, again, segregated by